Hi everyone, welcome to another webinar from SQL Maestros. Glad to see all of you today online. Today's topic is the performance difference between the between operator and the in operator. For today's webinar, I've done something different. The entire demo of today's content has been pre-recorded. It's a 45-minute module, a video that I'm going to play. I wanted to do that a little differently because the content and today's demo is like a story. I take just a couple of queries, one with the between operator and the other one with the in operator, and that's it. We keep comparing the performance difference between the two queries, and it starts like a story, like a movie, and at the end we have the climax. So I didn't want that there is any interruption in between, and I didn't know how much time will that really take, and that is why I thought it's better to pre-record it so that we finish it off in the stipulated time of 60 minutes. So the demo content, the module is 45 minutes, well recorded and edited so that you get the content, and it's slightly advanced. So please make sure that you have full attention and you focus on the content and the demo. And now you're thinking that, okay, if it is pre-recorded, how do you ask questions and how do I answer your questions? Well, the way we always do, which is while the demo and the content is going on, keep punching your questions in the Q&A panel of the Zoom toolbar. And while the video and the demo is going on, I will answer it while typing. So I'm going to type and answer all your questions. Make sure you don't put your questions in the chat window. I repeat again, please use the Q&A window. You ask your questions there by typing, and I'm going to answer it by typing. So before we jump over to the content and the demo, just a very quick introduction about SQL Maestros and myself. My name is Amit Bansal. I've been working with SQL Server for a couple of years now. My focus is SQL Server performance tuning. This is what I've been doing over the last 2 decades. I work in SQL Maestros, and primarily we do 2 things here. We do a lot of consulting work around SQL Server performance tuning, query optimization, fixing performance issues, identifying root cause of bottlenecks, diagnosing them, etc., etc. And all the learnings that we get, we package them into webinars like these, free tutorials, videos, premium tutorials, video courses, master classes, etc. All of that is available on sqlmaestros.com. The link is there in the chat window. I'll just take 2 minutes and quickly introduce you to whatever is available on SQL Maestros. First thing, a common question that keeps coming in all the time, which is about the webinar recordings. So when you go to sqlmaestros.com, and I am on the homepage here, you can explore all our services out here, some latest videos that we keep posting each week. And as you go up here, you have all the key offerings, the highlights. And here you go, there is a recorded webinar section. If you click on browse recorded webinars, you come over to this page where you will be able to see loads of webinars that we have been doing this year. All of them are recorded and are available for a lifetime subscription. Most of them are free, but some of them are very nominally priced. That just helps us to keep the show running. Now, if you're thinking, oh, there are so many webinars, do you need to really go and subscribe to each one of them? No, not really. You can join SQL Maestros as a member. So here you have a join link there. So let me just click on that link and jump over to the join page. You can become a free member, and as a free member, you really don't pay anything at all. You get access to all our free tutorials and the free webinars. But if you're interested in some advanced content, which is like premium tutorials and some paid webinars, you can take up the premium membership. So if you're just keen on one paid webinar, you can pay that very small fee and access to that webinar for a lifetime. But if you really want everything, you can take up this yearly premium membership. You get what we have already and all the upcoming content for the next whole year. When you become a free member, either a free member or a premium member, now for free members, we have the different lobbies, and I will just want to show you the 2 lobbies there. There you go. So here is our video library. This is our free level membership video library where you can see all the free SQL Server tutorials and the webinar. And here you go. This is our premium level membership library where you have all the advanced tutorials and all the paid webinars. All the links are available in the video lobby section here. And friends, also take a look at our upcoming masterclass, which is right here. So we have the SQL Server Performance Tuning Masterclass. The link is here, live masterclass. This is a 40-hour program that we are running very soon. The dates and the time are all up here. 40 hours divided in 2 weeks, 4 hours each day. So 2 consecutive weeks. So this really helps you balance your job timings and the learning. The best part is you get to attend live and you get the recordings also. The entire masterclass is going to be recorded and you will get a lifetime access to the recordings. Take a look at the content from module 1 all the way to module 14. The focus is internals, performance tuning, and query optimization. You should take a look at this masterclass only if you're interested in some deep dive content around SQL Server, around some real world stuff. If you're not a fan of live masterclasses and you want more self-paced learning solutions, I will take you to the all-in-one bundle here. Again, lifetime access to this as well. It's a package of all our video courses and masterclass recordings. So all these links are available. There are too many things out there on SQLmaestros.com. We have free stuff. We have things with very little fee, and you have some real good advanced learning solutions also. All the links are there in the chat window. Whenever you have time, take a look at them. If you have questions, you can drop a mail to contact@SQLmaestros.com, and someone from our team will answer to you. All right, that's all about the introduction to SQL Maestros, what we have, and now it's over to today's content, today's demo on between versus in. So I'm going to switch off this video and start over the next video, which is a pre-recorded demo, and I'm live. I'm answering questions as you watch the demo, as you watch the content. Hopefully you will like it. Switch over to the next video. Here you go. Hi friends, we have a very interesting concept here, the performance difference between the between operator and the in operator. There's so much discussion about these two operators as to which one is faster. Is it the between operator or the in operator? And there's so much content on the internet where people try to compare between the two. If one was always faster than the other, you would never use the other one. So there are some content, some demos that show you that both are equally good and SQL Server Optimizer will automatically take care of things. You may choose either one. There's another section of people and demos that show, okay, between goes faster than the in operator. And then there's other section of the content which shows that in goes faster. So there are all sorts of content and demos and explanations about these two operators. Of course, in their own demos and the content, they're right and they try to show things, and it's great and good and you should go and read that. So I thought, why not put all of this together so that you get the complete picture, the 360-degree angle of what really happens inside the SQL Server engine. And this is where I do this video. And this video is just the starter, just the beginner, because when you take these operators and start doing comparisons, there are so many different permutations that you can bring about. And this is what I'm trying to show you as to when you're testing things, you got to look at all possible angles. All right, let's get right away into the demo and see this for ourselves. We're going to use AdventureWorks 2016 for the demo. Let's pull this results pane a little down. We have a table here, person.person. You have seen me earlier using this table quite a few times, and this table has a few attributes like first name, last name, and then there is one called email promotion. I'm calling out these attributes because these are the ones that we are going to use in the demo today. First things first, we'll make a copy of this table and we'll call this as person.contact2. Okay, let's go and do that. I don't know why am I not calling it as person2, but anyway, let's call this. Okay, so we already have this table. Let me drop this table because if I have any indexes, everything will get dropped. Okay, so we drop the table. Let's go and create the table again. So now we have this table person.contact to a brand new table with 19,972 records. And you know that this is just created now, so it is a heap, which means there is no clustered index. Now we are going to create a clustered index on the attribute business entity ID. Let's do that. So informally speaking, this is a clustered table now. Let's go and verify that how many indexes we have on this table now. We use the system stored procedure sp_help index, and you can see that we have a clustered index and the index key is business entity ID. So the point to be noted, no non-clustered indexes just yet. Now I'm going a little back and starting things from very beginning, and then we'll come to the crux of the content in just a while. Now we have two SQL queries here. Both of these select statements are getting all the columns from this contact to table, from the base table. So if you look at the first one, select star from this table where email promotion is between 1 and 2. So in the first select query, we use the between operator, and in the second one, we are using the in operator. So if you look at the phrase there where email promotion is in 1, 2. Now, I will right away not jump into the difference between the between operator and the in operator or how the optimizer treats them. We'll look at a few examples, then we'll talk about the technicalities here. Now, the syntax is very, very straightforward to use. So between 1 and 2, and this one is using the in operator. Okay, let's go and run both of them together. And when you run both of them together and the actual execution plan is turned on, so either click on this icon, small icon there, or press Ctrl M so that you can get the execution plan. Let's do this and see what does the optimizer really think. You're getting all the data and you have put your filter. Let's jump over to the execution plan and look at the result set there. Now for both of these execution, first things to be noted here that we are performing a clustered index scan. Not we, not you and I mean the optimizer, right? The execution engine is performing a clustered index scan for both of them. And if you look at the performance comparison, let's zoom in, both of them are 50%, which means for the optimizer at this very moment, the between operator and the in operator is equivalent in terms of performance and also in terms of execution, in terms of the plan itself, the access methods that the operator is using, the cardinality estimation, the scanning, the seeking, or whatever you call it, they are identical. Both these plans are right now identical, and that's why you get 50% and 50% in terms of performance. So this is a clustered index scan, and it is well understood why this is a clustered index scan, because there are no non-clustered indexes. All right, now let's scroll down, and now we are going to create a non-clustered index. So I choose two attributes here, email promotion. And you know why am I using email promotion? Because email promotion is one of the columns that is being used in the where clause. I am also creating, I'm also using another attribute here, another index key, which is first name. And this will be evident to you in a while. Why are we using first name here? So I put first name as well. So we are creating a composite index, email promotion, comma, first name. And both of these attributes are index keys. I'm calling this out specifically because we are not using the include keyword. So in this demo, there's no concept of include here. Both of them are index keys, and this is the order of columns, email promotion, comma, first name. It's important for me to call this out, and you should also remember that the order of columns do matter in an index formation. So email promotion, comma, first name is not the same as first name, comma, email promotion. Anyway, I shouldn't be talking too much about that right now because it is not relevant. You know, even though first name is an index key here right now, don't worry too much about that, because the query, both our select statements are not dealing with first name at all. And email promotion is the first column which solves the purpose. So all that we're trying to do is we want to seek, right? And that is the reason why we put email promotion as the first attribute. So after email promotion, whether you have first name or last name or middle name or any other set of attributes really do not matter right now, given the context of these two queries. Okay, so let's go and create this index. All right, index created. Now we will run the same queries again, which is get all the columns. So we have star, star. This is same as what we did earlier. Let's go and execute. Now, some of you might be thinking while you're watching this, okay, now the index is going to be used. Let's check that out. Jump over to the execution plan, and our indexes are still not being used by the optimizer. The optimizer still decides to do a clustered index scan, both for the between operator and the in operator, and the performance is 50% again for both of them. So this is the same execution plan that we got earlier. So a simple answer to why the index was not used, because we are asking SQL Server to give us all the columns from the table. Select star is the culprit here, because you're asking for all the columns. The index only has first name and email promotion. Okay, I should say the index only has email promotion and first name, only two attributes. It also has business entity ID, because every non-clustered index includes the clustering key by default. So it has 3 columns, but you know this table has like more than 10-15 columns, so you want all of it. If you ask SQL Server and tell SQL Server, hey, you know, why didn't you seek on the index and then do a lookup on the base table to fetch other columns? The optimizer will simply tell you, hey, that would have been more expensive, which is looking up on the index and to fetch the additional columns, doing a lookup from the base table. The seeking plus lookup would have been more expensive. Because you're asking for all the columns, the easiest thing to do is just go and scan the data and fetch out everything that you need and render it to you. Okay, so this is simply a cost-based decision. All right. So that is why SQL Server decides to use the same clustered index scan operator. Now things will change a bit and things will start spicing a bit. We are only asking for email promotion attribute, right? Star gets replaced by email promotion, both in the first query, which uses the between operator, and the second operator in. Again, so let's go and execute both of them now. And this doesn't really even need a guess, because you know what's going to happen. So let's jump over to the execution plan now. And if you see, SQL Server, as expected, will now seek on the index that you created. So this is seeking on email fname. This is seeking on same index, of course, IDX email fname, and performance wise, both of them are 50%. All good until this point, and everything is working as expected. Okay, we're already like 10 minutes into this demo and we haven't still come to the crux. We are coming. We're just building up our knowledge. We're just building up from step 1 to step 2 to step 3. Okay. Now, friends, all good as expected. Index is being used. We have started using the index. This is what we wanted. Now comes the tricky part, right? So now we are asking SQL Server to give us email promotion and first name. Okay, so we want these two attributes, and we that's the only change we have done to both the queries. So as always, the first query is using the between operator and the second query is using the in operator. We just add first name to the equation. You know that first name is already part of the index, right? The one that we have created. So is anything really going to change? Let's go and execute and jump over to the execution plan. And if you look at the execution plan, it is identical again. Nothing changes. You still have index seek on the index that you created in both cases, and you have 50% performance. Equally good, identical plan. Both of them have the same performance from an optimizer's perspective. You know, when we look at all these plan comparisons, we are only looking at the execution plan, which is the estimations by the optimizer. But just to call this out, because you shouldn't feel that's the de facto way of doing things. When you are running queries and looking at the execution plan, whether you look at queries in an isolated fashion or whether you compare them with other queries or other rewritten versions, always look at actual numbers, which is the read numbers, the CPU time, elapsed time, etc., which is the runtime statistics. That is important. In this particular case, it is not important, so I'm not jumping over to that. I'm only sticking to how the optimizer works. But in real world, you will always look at runtime statistics whenever you're baselining, benchmarking, or comparing performances. So that's just to call out. All right. So we were here, we were looking into email promotion and first name. We get the same plan, all good. Now let's add first name in your query. Now things will start really interesting, and things will spice up a bit. Look at the query. The query has changed a bit. Earlier, we only had email promotion in our where clause. Now we also add first name in our where clause. So we say first name like Lolan, percentage, okay, whatever. That's one of the names there. And we do exactly the same in the second one. So we have introduced another attribute here in our filter, in our predicate, which is first name. And of course, the criteria is also identical. Email promotion, however, remains same. So we have email promotion between 1 and 2, and here email promotion in 1 and 2. This is what has been since the very beginning. Now, when you go and execute this, you will start noticing differences now, okay? And this is where the behavior of the optimizer will be questioned as to what's really happening inside the engine. Now, before I run this query, again, just a reminder, first name is part of the index. And now you understand why I actually created the index with first name also as the second column. So you already have an index, right? Which is on email promotion, comma, first name. And the order of columns is email promotion, comma, first name. Let's go and execute this now. Jump over to the execution plan. Now let's scroll down a bit here. Okay. The first thing that you are going to notice here, and to many of you as a surprise, let's pull this up a bit, is first things first, both of these plans look identical. Okay, let me zoom out a bit there. Okay, so you can see both of them together. Yeah, both of these plans look identical, right? So you have an index seek going on email fname, and then SQL Server decides to do a key lookup. Fair enough. And then you have an index seek happening again here with the in operator, and then SQL Server deciding to do a key lookup. Plan looks identical, but what about performance? Look at this. So SQL Server decides to do 84% here and 16% here. So performance-wise, SQL Server thinks that, or estimates that, this is more expensive, much more, I mean, maybe like 5 to 6 times more expensive than this one. So this is the between operator, and this one is the in operator. When you look at examples like these, you tend to believe that, okay, the in operator is working faster and the between operator is slower. But just hold on. Now you are seeing we are coming to the crux of the demo here, and the behavior of the optimizer, how the optimizer is treating your query with the between operator and the query with the in operator. So what you have seen, between operator is turning out to be more expensive, and the in operator is turning out to be less expensive. But what is baffling you and me here is the plan looks identical. That is baffling us. Okay, so first let me just zoom out here and just tell you one more thing, that the query was changed a little in sense that we started using star again, right? I didn't call out that earlier because I wanted to bring that key lookup into picture, into the overall equation. That doesn't really change too many things, but just calling this out, that to make the plan a little more realistic and to do that performance comparison. So both of the queries are still identical in sense that the first one is also asking for all the columns, and the second one is also asking for all the columns. Later, when you have this script and you're practicing this yourself, which you can very easily, try to just put email promotion and first name there. Okay, so we have the select star, and we worked on both of these columns. Coming back to our original discussion, the plan looked identical. We had key lookup in both of them. That is because of the star. So that clears out that first question. The second is, some of you might be thinking about the order of columns. You might be, hey Amit, the index is created with email promotion comma first name, but your query has first name and then email promotion. Does it really make a difference? The answer to that is no. It does not make a difference as to what is the order of columns in your query. So whether you write first name and then email promotion, or email promotion and then first name, does not matter. The order of columns in your query does not matter, but the order of columns in your indexes do matter. That's very, very critical. So you know, when you create an index, specifically multi-column indexes, data is sorted in that particular fashion, right? So you have data sorted by column first, comma column second, comma third column, so on and so forth. So of course, column 1, comma column 2 is not the same as column 2, comma column 1. I mean, the so-called structure is same, but of course the data, the way data is sorted and stored is different. And if that is different, seeking and traversing the index becomes different. Well, that being said, remember, we are still dealing with only one index. We just have one index with email promotion comma first name. And now we are looking at this query, and we saw this behavior where we get the identical plan and we see that there is a performance difference. So I answered two things, just a quick summary. I answered two things: that because of star, key lookup came into the picture, which is fair enough. That's not really much to discuss about. And I answered the second question about the order of columns, right? So order of columns in the query does not matter. So we are still, with these two being answered, we still have that confusion and that understanding. Okay, why is between becoming expensive here, and why is an in operator less expensive? The third question that might come to your mind, and may be coming to your mind while you're watching this, is the order of column in the index itself. So if you have this query which is given this option of index email promotion comma first name, SQL Server chooses that index because that's the only index available. You are thinking now, hey Amit, you know, why not change the order of columns in the index? In that case, will between be more expensive, or will in continue to be less expensive, or will it go reverse? In will become more expensive, between will become less expensive. Can that happen, etc.? So let's do one thing. Let's change the index now. Okay, so what we are going to do is we will drop this index, which is, I've named the index that way, email underscore f name. Let's drop this. Okay, and let's create the other index that you might be wanting to do, which is first name comma email promotion. Let's do that. Now we have changed the order of columns, and I will maintain my statement, which is the order of column in the index does matter, but the order of columns in the query do not. Okay, time to check again. The same workload, same query we are running again, select star, select star. We have first name, then email promotion using the between operator, and the second one using first name and email promotion with the in operator. Now the index has changed. Let's go and execute this. Now let's jump over to the execution plan. Let's see what happens. Where you go, and now you will find something very interesting. Let's zoom out a bit there. Okay, so what SQL Server has done here again, again you see an identical plan. You again see index seek with key lookup, here index seek with key lookup, but now performance wise both of them are 50%. So this looks identical, this looks equivalent. So you had the same plan earlier as well. Now whether that was the same plan as this one, we'll talk about that a little later, because there is some there's some suspense to that. Of course, there has to be, because even though the plans looked same, there was a cost difference, 84 and 16%. But in this case, both of them are 50%. So I'm assuming that, of course, these both plans look identical, and their performance, their cost is also 15% relative to the batch is same. So they are identical. Okay, so you change the order of columns in the index, you got this. So as per this example now, where you have changed the order of column in the index and you gave that index to the optimizer, between and the in operator are performing equally well. So between is not winning over in, and in is not winning over between. But in the earlier example, when you had a different index, in was winning over between, 16% versus 84%. Okay. Wow, this is going super suspenseful, okay? Thriller. Okay, let's do one thing now. Let's create that first index again, and let's give both the indexes to the optimizer, okay? This is going to be super interesting. So create index IDX email fname, where you put email promotion and first name. This was the first index that we had created. Now, when you create this index, okay? When you create this index, now the optimizer has both the indexes, the index with email and first name, and the index with first name and email. Now we are checking these two queries once again. What's your guess? What's your guess? Which index will the optimizer use? Will the optimizer use this one with email promotion and first name, or will the optimizer use first name and email promotion, the other one? Let's take 5 seconds, think about this. 5, 4, 3, 2, 1. Think. Which one will the optimizer use? Okay, you've made your decision. Let's go and run both the queries, the between and the in. Let's go and execute. Jump over to the execution plan. And what do you see? Let's zoom out a bit. Okay, just take a look at both the execution plans. Look at everything. Look at the finer details. Is everything identical, or is there a difference? If you look at both the execution plans, both these plans are looking identical. Yeah, we are doing an index seek. We are doing an index seek. We have a key lookup. We have a key lookup. All good. And the performance is 50% for both of them. But friends, look at this. The first one, the first query with between operator decides to use the index with first name and email promotion. And the one with the in operator decides to use the index with email promotion and first name. So between operator and the in operator, both of them decide to choose a different index. This is what the optimizer is doing now. Given the choice of the index, the optimizer has taken the right index for the right operator. And that way, performance-wise, both of them are performing equally well. The plan looks identical, but in general, the plan is really not identical, because both of them are using different index. The puzzle is still not answered. What is happening behind the scene? Why is the optimizer choosing one index with the between operator and the other index with the in operator? What are the rules the optimizer is playing by? If you want to watch the remainder part of the webinar and all the remaining demos, you can subscribe to the webinar on SQLmaestros.com and get lifetime access to the recorded webinar. All you have to do is just go to SQLmaestros.com, click on the recorded webinar section and get access to all the webinar recordings. There are many of them. Some of these webinars are free and some of them are very nominally priced. So the ones that you're interested in, you can subscribe to them and get lifetime access. Now, because there are so many webinars, subscribing to each webinar might be a bit cumbersome. So we have another option, which is SQL Maestros membership. So the first link on SQL Maestros says join. If you click on that, it will bring you to SQL Maestros membership. Things are very simple. There are two membership levels. The first level is free, where you get access to all the free webinars and all our tutorials and demos, more than 200, 300 demos and tutorials. All you have to do is just become a free member. You're paying nothing and you get access to all of them. So you don't have to go and subscribe to each webinar individually. Just become a free member and then explore the free video lobby. So if you go to the video lobby here, there is something called as free content where you get access to all of that. But then all of us are interested in advanced content, isn't it? And that is where premium membership comes into play. So the webinars that are paid, and there are many advanced tutorials and demos. If you want access to all of them, you can become a premium member and pay a nominal price, which is annual membership. Once you do that, you can explore the premium video lobby. If you go to the premium video lobby from here, or just go to the video lobby and click on premium content, you can see all the paid webinars and all the advanced tutorials and demos and get access to all of them with your annual membership. Anyway, choice is yours. There's a lot of content on SQLmaestros.com, and you can also explore the YouTube membership level as well. So you have free content on YouTube channel, and you can also join and become a member of SQL Maestros on YouTube, where you can pay a monthly fee, get access to all the paid webinars and advanced content. So in summary, you can go to SQLmaestros.com and become a member, or you can become a member on YouTube also. Becoming a member on SQLmaestros.com turns out to be a little cost effective with the annual membership in comparison to YouTube monthly membership. But anyway, choice is yours, whichever platform you wish to use. Happy SQL.